Yeah, hello everyone. This is Srinivas, your maths faculty. Welcome to Akshara IIT Foundation. So today we are going to discuss about the new chapter, theory of equations. Okay, na? So let us go to the theory of equations. We need to learn some terms here. Let us see that. We need to discuss about a polynomial first. That means term, algebraic expression, numerical expression, whatnot. We have already learned about it. So first polynomial. Polynomial is nothing but an algebraic expression involving variables with non-negative integral powers. Involving variables with non-negative integral powers. Yeah. For example, let us see one polynomial. One of the algebraic expressions, let us discuss once. So x power 3 plus 2x square minus 5x plus 6. This is an algebraic expression involving four different terms. X cube term, x square term, x term and constant term. While you are observing about the variable here, its exponents. What is the exponent here? 3, 2 here not there anything means 1. So while you are observing that, the powers of the variable is non-negative. Powers of the variables is non-negative. So an algebraic expression with non-negative integral powers is called polynomial. Integral powers are nothing but integers, non-negative integers. Okay. For example, x power 2 by 3 plus 5x plus 6. While you are observing the first term, it is having the exponent is 2 by 3. So 2 by 3 is nothing but is in the form of p by q. P by q is rational number, not an integer. So from this case, we need to identify that the given polynomial is, the given expression is not becomes a polynomial. According to definition, it must be non-negative integers or non-negative integral powers. But here 2 by 3 is not an integer, it is a rational number, so it is not belongs to the polynomial. Okay, right. So let us discuss some general forms of the polynomials. For example, here a polynomial having a degree 1 is called linear polynomial, degree 2 polynomial is called quadratic polynomial, degree 3 cubic polynomial and degree 4 biquadratic polynomial. Let us see here. Polynomials of degree 1, 2, 3, 4 are respectively. Degree 1 is linear polynomial, degree 2 quadratic, cubic, biquadratic, degree 5 pentic, hexic, septic, octic, like that. Okay, na? And general form is ax plus b. Linear polynomial general form is ax plus b. Its degree 1. Degree 1 polynomial is called linear polynomial. Let us identify the number of terms also. Here how many terms are involving here? 2. But here terms are not particular, it depends. But in general form, if you are identify the 2 terms containing here. Now, quadratic polynomial general form ax square plus bx plus c. 3 terms. Degree 2 polynomial is called quadratic polynomial and it contains 3 terms. Degree 3 polynomial ax cube plus bx square plus cx plus d. Degree 3 polynomial is called cubic polynomial and it contains 4 terms in general form. Next, degree 4, ax power 4, bx cube, cx square plus dx plus c. Here 5 terms, degree 4, 5 terms. Because while you are observing here, I am using the alphabet, each letter in the alphabet for writing the general form of the polynomials. A, B, C, A, B, C, D, A, B, C, D, E like that. Okay. Because we know that number of letters in alphabet are 26. That means if you write 25th degree polynomial, all 26 letters will come. A to Z. In case if they ask 50th degree polynomial, we have only 26 alphabet now. So that's why we are taking the alphabet. Instead of alphabet, we are taking the coefficients. These are called coefficients. Here A means x square coefficient, B means x coefficient, C constant term. That's why we are taking the coefficients as A0, A1 or A0 also you can write A0, A1, A2, A3 and so on. how many you met, that many coefficients you can take. Okay, now for example, a polynomial is asking about the nth degree polynomial is asked. N can be any number, n can be 50, 100, 500, what not. If it is asking about nth degree polynomial, we'll write the general form as a naught x power n. Nth degree polynomial highest power must be n. Here see second degree polynomial highest power 2, third degree highest power 3, fourth degree highest power 4. Okay, nth degree polynomial is highest power must be n. A naught, next a1 x power n minus 1. Here x cube, x square, x like that. X power 4, x cube, x square. That means 1, 1. Exponent value is 1 is decreasing like that. Same way, n after, n before n minus 1. N minus 1 before number is n minus 2. And so on, like last one an. Last one is nothing but constant only remains. Here, there is no involvement of x here. So this is the general form of nth degree polynomial, where a naught nothing but coefficient of x power n. Here the condition is not equals to 0. A naught value is does not equals to 0, because if a naught value becomes 0, then it could not be nth degree polynomial. Okay, na? It could not be a nth degree polynomial. Okay. Now, if a polynomial is f of x is equal to a naught means only the first one. A naught into x power n I did not give, only a naught, that is nothing but coefficient. Nothing but that polynomial is called constant polynomial. Constant polynomial. That means, for example, we can take 5. Only number 5, constant number I given. This polynomial is called constant polynomial or degree 0 polynomial. Degree 0 polynomial, because 5 we can write as 5 into 1. 5 we can write as 5 into 1. That means 5 into 1 we can express as x power 0. According to the law of exponent, we know that the degree or any number power 0, a power 0 equals to 1. Same way, x power 0 equals to 1. This 1 we are representing like this, then we can identify its degree is 0. So, degree 0 polynomial is called constant polynomial. Okay, na? Yeah. Let us check here. F of x is a polynomial of degree n. F of x equals to 0 is called nth degree equation. Nth degree polynomial equation. Okay, na? Polynomial equation of nth degree. Here until then see, I did not write any equals to 0. Whenever you keep equals 0, the polynomial becomes an equation. Okay, na? That expression becomes an equation. Same way here, it is given the n, if you take any nth degree polynomial, that f of x is equals to 0. Whenever it is equals to 0, that polynomial becomes an equation. Nth degree polynomial becomes an equation. Okay. Same way, the solution or root. Root of the equation or solution of an equation. So, root or solution is nothing but if you substitute any one of the value, that can be real number or integer, rational number, it doesn't matter. If you substitute any value in the place of variable, that should be equals to 0. That means entire equation value becomes 0. Then we can say that that is root of the equation or solution of an equation. Okay, na? Root of the equation or solution of the equation. For example, f of x, a polynomial is given that 3x minus 6. 3x minus 6 is a linear polynomial I have taken. In the place of x, if I substitute 2, in the place of x, I have substituted 2, then 3x is nothing but 3 into 2 minus 6. So, 3 2s are 6, 6 minus 6 is 0. That means here 2 is called solution of the equation or root of the equation. Solution of the equation or root of the equation. Okay, na? Yeah. Let us go to the next one. Okay, sorry for that. Yeah, here. Let us see one example here. If alpha is the root of the equation is x power 4, plus x cube minus 4x square plus x plus 1 equals to 0. This is the polynomial or equation which is having the degree 4. Highest power is 4. That is nothing but biquadratic equation. Now before going to find out the solution of this quadratic equation, let us discuss 2 points. Let me discuss a point, that is, if a polynomial having degree n or degree 1, that polynomial having one solution. Degree 2 polynomial, mostly we have two solutions, at most two solutions. Degree 3, at most 3 solutions. Degree 4, at most 4 solutions will have. That means the polynomial having the solutions based on their degree. If a polynomial having nth degree polynomial, if you take, there are n solutions or no solution. No more solutions also will be at the chance, one of the chance. Okay, na? Yeah, let us check it. Now here degree 4, you will get 4 solutions. That means the solution also given, that is alpha. Alpha is the root of the equation, nothing but solution of an equation. We need to identify the value, or we need to find the value of alpha plus 1 by alpha. Alpha plus 1 by alpha value we need to find. Okay. According to the root of the equation, we discussed that when you substitute the value in the equation, that becomes solution or root. Let us substitute alpha in the place of x. That is alpha power 4 plus alpha cube minus 4 alpha square plus alpha plus 1. But we need to identify alpha plus 1 by alpha. It is somewhat risky task for us, that means somewhat difficult task for us. But we have to convert them in the form of 1 plus alpha plus 1 by alpha. Try to convert them into alpha plus 1 by alpha form. So from using this only, I am going to divide the entire equation with alpha power 4, alpha power 2. Divide this equation both sides by alpha square. That means alpha power 4 becomes alpha square, because divided by square now. So 4 becomes 2 then. Now here alpha cube becomes alpha, and alpha square, denominator alpha square cancel, only 4 remains. Here numerator only 1 alpha, denominator alpha square. So 1 by alpha will be forms, and here 1 by alpha square will be forms. Now see here, alpha I got, 1 by alpha also I got. I need to identify these two. That's why I have divided the entire thing with alpha square. Okay, that equals to 0. Now I am writing this one, alpha square like alpha whole square, and this term and this term, first term and last term. Last term also I can write like this. It is like a square plus b square. I would like to convert them into a plus b whole square format. A plus b whole square format. A square I got, b square I got, 2ab I should get. 2ab means what? 2 into alpha into 1 by alpha. So alpha cancel, 2 ones are 2. I want 2. So I am adding 2. Here only subtracting the number 2. Next remaining, these 3 terms are remains. So these 3 terms I am writing in an order, that is alpha plus 1 by alpha minus 4. Okay, na? Now from these first 3 terms I can write in the form of alpha plus 1 by alpha whole square. Nothing but is in the form of a plus b whole square formula, one of the algebraic identity. Okay. Now minus 2 minus 4 becomes minus 6. That means alpha plus 1 by alpha minus 6 equal to 0. Now let us assume alpha plus 1 by alpha as t. Let alpha plus 1 by alpha equals to t. Substitute in the value, it becomes t square minus t minus 6 equal to 0. Nothing but quadratic equation. This quadratic equation, 2 roots, let us identify the 2 roots. Because we need to find only alpha plus 1 by alpha, no? T value we need to find. That's it. So from this minus 6 we can express 3 2s are 6, but we should get minus 6 now. So minus 3 plus 2 minus 6. So this I can express t square minus 3t plus 2t minus 6 equal to 0. That means minus t only I have expressed by using these factors 3t and 2t. First two terms t minus 3 common, next t plus 2 common. So t minus 3 equal to 0, t equals to 3. T is nothing but alpha plus 1 by alpha is equal to 3. We got it. Our second one, t plus 2 equal to 0, t equals to minus 2. That means alpha plus 1 by alpha equal to minus 2. Got it. So therefore the answers are 3 and minus 2. Please check it. So let us go to the next question. Yeah, fundamental theorem of algebra. Let us see here. Every polynomial equation of a degree 1 which is greater than or equals to 1. If you take any polynomial degree n or greater than or equal to 1 has at least one root. I told you already, if you take any polynomial with degree 1, minimum 1 equals to 1 or more than 1. 1 degree, having 1 degree polynomial having 1 solution, degree 2 polynomial, 2 solutions, 3 polynomial, degree 3, cubic polynomial, 3 solutions, like. Okay, minimum we need to take degree 1 polynomials it seems. It is having at least one root. Okay. Next, every polynomial equation of degree n has how many n roots? Degree 4 polynomial equation having 4 roots. Degree n polynomial having n roots. N roots are no more. Okay. In an equation with real coefficients, that means if you are taking any polynomial, their coefficient like a0, a1, a2, we are comparing that nth degree polynomial with a0 x power 1, x power n, a1 x power n minus 2 plus a2 x, a1 x power n minus 1 plus a2 x power n minus 2, like that we have written one general form, right? Yeah, in this general form, a0, a1, a2, these coefficients, if they are in the form of real numbers, then you will get the roots in imaginary roots. Nothing but conjugate pairs. Imaginary roots are nothing but conjugate pairs. Imaginary roots are nothing but is in the form of a plus ib. A plus ib, where a is real part, and b is imaginary part. Okay, na? That means 3 plus ib or 3 plus 5i. Okay, na? 3 plus 5i. It is in the form of a plus ib. And its conjugate is 3 minus 5i. Okay, na? So they are having conjugate pairs it seems. Imaginary roots and conjugate pairs it seems. Which one? If the coefficients are real numbers. Okay. Same if the coefficients of rational numbers, rational coefficients, you will get irrational roots. And pair of conjugates. Irrational roots means root 2. Its conjugate is also a root 2 or minus root 2. Okay, na? Minus root 2. Or 3 plus root 2, we can have 3 minus root 2. These are all conjugate pairs only. Or else we can take minus 3 plus root 2 also. These are all conjugate pairs. Okay. So that means simply polynomial having real coefficients, imaginary roots with conjugate pairs, or the coefficients are rational ones or rational numbers. Their roots will be irrational and conjugate pairs. And the function of a roots, function of the roots of an equation which remains unaltered values. Okay, na? So the values will not be changed. There depends on the conjugate pairs and all. Okay, let us see. When any two of the roots are interchanged, if two of the roots are interchanged, that is called symmetric function of the roots. So we'll discuss about this point while we're doing the example problems. Okay, na? Yeah, let us go to the next concept. Now remainder theorem and factor theorem, very, very important. By using this remainder theorem, we can directly identify the remainder. Okay, na? So remainder theorem is nothing but a polynomial whose degree is greater than or equals to 1. Where f of x is a polynomial whose degree is greater than or equals to 1. F of x is a polynomial whose degree is greater than or equals to 1, and a is any real number. A is any real number, and if f of x is divided by x minus a, x minus a is linear polynomial. If f of x is divided by x minus a, then the remainder is f of a. Remainder is f of a. That means if a polynomial f of x is divided by x minus a, its remainder is f of a. If the polynomial is f of x divided by x minus 2, remainder is f of 2. Same way, polynomial is divided by x minus 5. What is the remainder? Very good, f of 5. Okay, sir, you are taking x minus a, x minus 2, x minus 5. In case f of x is divided by x plus 7, what is the remainder? F of minus 7. Because this also we can express x minus of minus 7. Then minus into minus becomes plus. Okay, no? So that we need to prove it. For example, let us take a polynomial. Let us take a polynomial f of x whose degree is greater than or equals to 1. Let f of x degree greater than or equals to 1. Sorry. Yeah, greater than or equals to 1. Okay. This is divided by x minus a. This is divided by x minus a. That means if it is divided by x minus a, f of x is divided by x minus a, remainder, let the quotient will be how many times? 1 time, 2 times, or x times or y times. Something will be there now in coefficient. The quotient is, let us take it as q of x, and we'll leave the remainder something is, that is as r of x. Remainder is r of x. Okay, na? Remainder is r of x. So according to the division algorithm, we can express this dividend f of x equals to divisor into quotient. That means x minus a into q of x plus remainder r of x. Nothing but division algorithm. Dividend equals to divisor into quotient plus remainder. By using the division algorithm, I have expression f of x. I expressed f of x is x minus a into q of x plus r of x. Okay. Here one point you should remember. What is the divisor? Divisor is x minus a. X minus a means which polynomial? Linear polynomial. That means degree 1. Whenever you do division, the remainder is always lesser than the quotient, divisor. Remainder is always lesser than the divisor. So if its degree is 1, the degree of the r of x is 0. Degree of r of x is 0. 0 degree polynomial what? Constant polynomial. Here we discussed. Degree 0 polynomial is called, where is it? Degree 0 polynomial is called constant polynomial. Constant polynomial. Degree 0 polynomial is called constant polynomial. So that means this will be any one of the number. That can be 0, 1, 2, 3, 4, 5, any one of the number it can be. Okay, na? So let us, this is equals to, the number is r. Okay, na? Yeah. Now, for suppose I am substituting one of the value a here. That means f of a equals to, in the place of x I am substituting a. Now here I'll substitute a minus a into q of a plus remainder r, because it is already known that it is constant polynomial. In the place of r of x I can write r. Okay, a minus a becomes 0. A minus a becomes 0. What is that? R. R means remainder. R means remainder. What is the remainder we got? F of a. That is only we need to prove. Remainder is f of a. So if a polynomial is degree greater than or equals to 1, a is any real number, it is divided by x minus a, then the remainder is f of a. We proved that remainder is f of a. Very, very important. Note it. Now let us see this one. Find the remainder of this polynomial, fourth degree polynomial, biquadratic polynomial, divided by x minus 1. If f of x is divided by x minus a, what is the remainder? F of a. Same way, let us take this polynomial f of x, that is equals to x power 4 plus x cube minus 2x square plus x plus 1. Yeah. If this is divided by x minus 1, what is the remainder by using remainder theorem? F of 1 equals to, f of 1 will be the remainder by remainder theorem. Okay, na? Substitute the value. In the place of x, write 1 power 4 plus 1 cube minus 2 into 1 square plus 1 plus 1 directly. 1 power 4, 1 only. 1 cube, 1 3 times you need to multiply, 1 only. 100 times also 1 only. 2 into 1 square, 1 plus 1 plus 1. Okay, 1 plus 1, 2. 2 ones are 2 minus 2. 1 plus 1, 2. Plus 2 minus 2 cancel, remainder is 2. Therefore, remainder equals to 2. Remainder equals to 2. Check one. I just substitute the value and simplified it. That's it. I did not do anything else. Special cases. No special cases here. Okay, now let us go to the next question. Yeah, let R1 and R2 be the remainders of a polynomial f of x and g of x. Two polynomials are given. F of x is a polynomial as well as g of x is also a polynomial. What is the degree of this polynomial? Just observe here. Highest power is 3. Yes, this is third degree polynomial, nothing but cubic polynomial. Third degree polynomial means cubic polynomial. Here R1 and R2 are remainders, it seems. R1 is remainder for f of x, R2 is remainder for g of x. Two polynomials which are divided by x minus 1 and x plus 2 respectively. That means f of x is divided by x minus 1 gives the remainder R1, and g of x is divided by x plus 2 gives the remainder R2. Then we need to find this value. That means 3R1 plus R2 plus 28 equals to how much? Okay, na? Yeah. Let us find out the remainder 1 and remainder 2 by using remainder theorem. So x minus 1 is remainder, then f of 1 is the remainder. X plus 2 divided by x plus 2, that means g of 2 is remainder here. G of 2 only, no? No, g of minus 2. Yeah, substitute here. What is the first equation? 4x cube. 4x cube, 4 into 1 cube plus 3 into x square, 3 into 1 square minus 12a into 1 minus 5. Simplify this. That is equals to 1 cube value 1 only, 4 ones are 4, 1 square value also 1, 3 into 1 3, 12 into a 12a minus 5. Check the answer. 4 plus 3 value 7, 7 minus 5 2. This is 2 minus 12a. This is remainder 1. Now let me find remainder 2. Remainder 2 means second equation. 2x cube. 2 into, in the place of x we need to substitute minus 2. 2 into minus 2 whole cube plus a into x square, a into minus 2 whole square, minus 6 into x, 6 into minus 2 plus 2. Whenever you have the negatives, you need to observe clearly. This is 2 into minus 2 whole cube. Minus 2 whole cube means minus 2 into minus 2 into minus 2. 2 2's 4, 4 2's 8, okay. But negative symbol, minus into minus plus, plus into minus, minus. So this is minus 8. So simply odd powers, negative will be negative only. When you have the even powers, negatives also becomes positive values. Okay. Plus a into minus 2 whole square. Minus 2 whole square means minus 2 into minus 2 becomes 4. Here minus into minus become plus. 6 2 is 12 plus 2. Let us identify this. 2 into minus 8 is minus 16. 12 plus 2 is 14. A into 4, 4a. From this, minus 16 plus 14, different symbol subtraction. Answer is minus 2 plus 4a. This is R2, remainder. By using the remainder theorem, we are just finding the remainders for this. But we need to find out that if it is given this becomes 0, find the value of a. A value we need to find. Substitute 3 into R1. 3 into R1 value is 2 minus 12a. Plus R2 value. R2 value is 4a minus 2. Minus 2 plus 4a, 4a minus 2 both are same. Plus 28 equal to 0. Yeah, 3 2s are 6. 3 12s 36a plus 4a. Yeah, minus 2 plus 28 is nothing but plus 26 equal to 0. Opposite symbols now. Now numbers. 6 plus 26 is 32. Transpose that side, minus 32. Minus 36 plus 4a is minus 32a. I want a value. Minus minus cancel both sides. 32 by 32, answer is 1. Very, very important problem. Check by using the remainder theorem. Yeah, that's it for today, children. Thank you one and all. Have a nice day. Tomorrow we'll discuss about the factor theorem. Thank you.